Picking up where we left off. Okay, we're on number 3 now. We have 7 over 56. So now we go off to the side and we take the prime factorization of 7, which happens to just be 7 because 7 is a prime number. So the prime factorization of 7 is 7. And now we take the prime factorization of 56. We know we had 2 times 28. 2 is prime, 28 is not. 28 breaks down to 2 times 14. And 14 breaks down to 2 times 7. So now, we know our numerator stays 7. Our denominator, we will have 3 2's and a 7. These 7's simplify out, and you're left with 1 over. Now 2 times 2 is 4, times 2 is 8. So it'll be 1/8. Now we go here to 56 and 84. What's good about this 56 and 84 is this here. We already had a prime factorization of 56, which was 3 2's and a 7. Now we just need the prime factorization of 84. So we could do that here. Now the prime factorization of 84, we have 2 and 42. Then we had 2 and 21. Then we had 3 and 7. So our prime factorization is 2 2's, a 3, and a 7. So we had 2 sets of 2's that simplify out and 1 set of 7's. So our final answer here is 2/3. Now, we scroll down here. It says algebraic fractions are fractions that have a variable and the numerator denominator of both. To simplify them, reduce the numerical coefficient as usual. Then write out the factors of any variables with an exponent. For example, if the fraction contains x to the 4th, write it as x times x times x times x. Can you reduce any other variables? Now we have examples. Example 1, we have 18x over 27x cubed. So first of all, let's find the prime factorization of 18 and 27. So 18 we know breaks down to 2 times 9. 2 is prime, 9 is not, and 9 breaks down to 3 times 3. So we add 2 times 3 times 3. That's the prime factorization of 18. Now the prime factorization of 27. We add 3 times 9, 3 is prime, 9 is not, and 9 breaks down to 3 times 3. So for 27, we add 3 times 3 times 3. Now, we're going to do this. 18 is 2 times 3 times 3, and we bring over our x times x. Now 27 is 3 times 3 times 3, and we add x to the 3rd power here, so we'll write out x times x times x. Now we simplify. They have 2 sets of 3's in common and 1 set of x's in common. So your numerator, you would just have 2, and your denominator will have 3 and 2 x's. So it'll be 3x squared. So our final answer here would be 2 over 3x squared. Now, we go to number 2. We would take the prime factorization of 12 and the prime factorization of 18. 12 breaks down to 2 times 6. 2 is prime. And then 6 we break down to 2 times 3. So now we have 2 2's and a 3. Now we go here to 18. 2 times 9. We know we break 9 down to 3 times 3. So we add 2 times 3 times 3. Now we substitute. We add 2 2's and a 3 for 12. And since we have b to the 3rd power, we'll write b, we'll multiply b 3 times. Now we look at the denominator. 18, we add 2 times 3 times 3. Then we add b squared, so that would be b times b. Now we simplify. One set of 2 simplify out. One set of 3 simplify out. And then with our b's, we had 2 sets of b's that simplify out. So our numerator would be 2b, and then our denominator would just be 3. Now, we scroll down here to section C. It says solve problems given answers in simplest form. In general, mathematicians generally agree to give fractional answers in simplest form unless there is a good reason to do otherwise. From now on, always assume that you should reduce your final answer to a fraction problem to simplest form. So this is basically saying whenever you do fractions, even if the directions do not tell you to do it, you must always write them in simplest form. Now, it says 6 weeks of the 16-week semester have been completed. What fraction of the semester is over? So what we would do is our complete semester is 16 weeks. What's over right now is 6 weeks. So we add 6 over 16. Now we can go off to the side here, do the prime factorization of 6, which is 2 and 3. The prime factorization of 16, we could break that down to 2 times 8, and then 8 breaks down to 2 times 4, and 4 breaks down to 2 times 2. So we have 4 2's here. So we have one set of 2's in common, and our final answer is 3/8. Now it says here, how many weeks of the semester are left? Okay, so now 6 weeks are completed, and it's 16 weeks. So we would take 16 minus 6, will leave us 10 weeks. Now it says what fraction of the semester is left. So we know our complete semester is 16 weeks, and we had 10 weeks left. Now we already had the prime factorization of 16, which was 4 2's, which we did in A. Now the prime factorization of 10, we know breaks down to 2 times 5. These 2 simplify out, and you will be left with 5/8. Now just take a quick moment here. If you notice, you have 3/8 and we have 5/8 here, and we're done with number 1. Now we go down here to number 2. It says getting an associate's degree requires earning at least 60 college credits. The chart below shows the number of credits Anne earned last year, her first year of college. It says A, what fraction of the credits she needs for her associate's degree did she earn during the fall semester? Now remember, she needs to earn 60 credits, so 60 would be our denominator. And then what she earned in the fall semester was 12. Now, in the previous problem, we did the prime factorization of 12, which was 2 times 2 times 3. And then we even did the prime factorization of 60, which was 2 times 2 times 3 times 5. Now, we can simplify this out. We have 2 sets of 2's and 1 set of 3. Now, in our denominator, we know it's 5. Our numerator, when everything simplifies out in your numerator, that leaves 1, because all of this is simplifying out to 1. So your final answer here is 1/5. Now we go here to B. It says what fraction of the credits she needs for her associate's degree did she earn during her first year? Now we add up all of these credits. 12 and 16 is 28, plus 8 is 36. So it's 36 over 60. Now we know the prime factorization of 60 is 2 2's, a 3, and a 5. Now for our numerator, the 36, I don't think we did the prime factorization of 36. So that's 2 and 18, this is 2 and 9, and this is 3 and 3. So we had 2 2's and 2 3's. Now, these two sets of 2's simplify out, and 1 set of 3's. So this would be 3/5. Now it says how many credits does she still need to earn? Now remember, she needs 60. She completed 36. 60 minus 36 will give her 24. Now it says what fraction of the credit she needs for her associate's degree that she still needs to earn. So now we write this in fractional form. It'll be 24 over 60. Now we know the prime factorization of 60 is 2 2's, a 3, and a 5. Now the prime factorization of 24, we have 2 and 12, and we add 2 and 6, and then 2 and 3. So we add 3 2's and a 3. Now we had 2 sets of 2's we can simplify out, and 1 set of 3's. So we're left with 2/5. And that. Now class, we're about to do section 4.2, section D, divisibility and prime factorization. There's another way to find the prime factorization. This way is called divisibility. Divisibility is a number that divides evenly, no remainder, into another number. In the chart below are a few of the divisibility tests using prime numbers. Now, you can read this at your leisure, but typically 2, 3, and 5, most of the numbers you're going to encounter, 2, 3, and 5, those numbers are divisible by them. If any of the numbers are even, you can divide it by 2. If you add up the numbers, like for instance 78, you add the 2 digits together, that gave you 15. If the 2 digits after being added together give you a multiple of 3, then the whole number is divisible by 3. Just like this, 222. It doesn't look like it would be divisible by 3, but if we add the digits together, that gives us 6. So that means 3 would go into 222 evenly. Now 5 is divisible by 5 if the last digit is 0 or 5. Okay, now there are some other divisibility tests, but these do not use prime numbers like 4, 6, and 9. Now with 4, if the last 2 digits are divisible by 4, which means if they divide evenly into 4, like say we had 304, the last 2 digits is 0, 4. Doesn't 4 go into 4? The answer is yes. Or we have 148. We'd take 48. Does 4 go into 48? The answer is yes. So we could divide 4 into 148. And then 6, if the number is divisible by 3, like when we did 222, when we added them up, it equal to 6. Now this has nothing to do with the divisibility rule of 6, that it equals 6. The main thing is it must follow 2 things. If it's divisible by 3, which this is, and if the original number is even, and it is, so then that means that this is divisible by 3. Like 78, 78 started off as even. You add the 2 digits together, it gave you 15, so it's divisible by 3. Now 9, if the sum of its digit is divisible by 9. So it basically follows the same rule as 3, except for when you add the digits together, they must be divisible by 9. Now these are some rules that you could use to help you solve certain problems. So I'm going to go through a few of these problems that should show you this here. It says find the prime factorization of the following numbers using divisibility. So we'll take 222. Now we know definitely that 2 can divide evenly into this. So it'll be 2 times 111. So that's a prime number. Now if we look at 111, if we add all of these digits together, that gives us 3. So we know 3 go into 111. So we add 3 times, so we could go off to the side. 3 goes into 11 3 times. 11 minus 9 is 2, and bring down your 1. 3 goes into 21 7 times, and we have no remainder. So it'll be 3 times 37. 3 is prime, and 37 is also prime. So the prime factorization of 222 is 2 times 3 times 37. Now, we come here to the next problem, 28. Now 28 is even, so we know 2 can go into it, and 2 times 14 is 28. But we also know that 14 is even, and 2 can go into 14, so it'll be 2 times 7 is 14. So we add 2 times 2 times 7. Now we scroll down here. 56. It's also an even number. So we add 2 times 28. There's 2. And 28 we could break down to 2 times 14. And 14 breaks down to 2 times 7. And see how the divisibility rules make it easy for you, because if you know it's even, automatically you know 2 goes into it. You know, if you add those digits together and it gives you a multiple of 3, you know 3 goes into it. And if it ends in a 0 or 5, you know that 5 will go into it. So we could take 30, since it ends in 0, let's just take 5. We know 5 times 6 is 30. Now we could break down 6 to 2 times 3. So we'll write this, we add 2 times 3 times 5. And that will be our prime factorization of 30. Now we go here to number 5, 72. We know 2 times 36 is 72. 36, if we add the digits, well, first of all, we can still divide this by 2 because it's even. So it'd be 2 times 18. And 18 breaks down to 2 times 9. And we know 3 goes into 9. 3 times 3 is 9. So our final answer is 3 2s and 2 3s. Now we got number 6, 117. Now we know 2 and 5 is not going to this, but let's try 3. 1 plus 1 plus 7, that'll give us 9. So we know 3 goes into 117. So now we could take 3 into 117. 3 goes in 11 3 times. 11 minus 9 is 2. Bring down your 7. 3 goes into 27 9 times. And you have no remainder. So 3 times 39. And 3 goes into 39 13 times. So you'll have 3 times 3 times 13. That is your final answer.